Hi there, I'm Katie and I'm a glaciologist at Aberystwyth University. I research glaciers and I'm particularly interested in valley glaciers. Valley glaciers are found particularly in mountain ranges such as the Alps in Europe and the Himalaya in Asia. And glaciers are really interesting because they're really key indicators of climate change. And I've just been involved in a project on Khumbu Glacier in Nepal. Khumbu Glacier flows off the flanks of Mount Everest, which you may know is the highest mountain in the world. And the way we wanted to look at the impact of climate change on Khumbu Glacier was to see how the temperature of the ice varies over time. So ice obviously is cold, we all know that, but the temperature of ice can vary quite a lot, from maybe -1 or -2 degrees, which is what we call warm ice, down to -20, -30 degrees, which is cold ice. We wanted to look at this for Khumbu Glacier. And to access the interior of the ice, we drilled boreholes across the glacier, and we did that using hot water. We converted a car pressure washer so that we could drill the borehole with a jet of hot pressurized water. And we wanted to access deep inside the glacier because near to the surface, the temperature of the ice varies following the surface air temperature. So warmer in the summer, colder in the winter. But once you get past about 20 meters into the ice, you start seeing the long-term stable ice temperatures, and that's what we really wanted to access. So once we drilled our boreholes, we inserted cables with sensors attached, thermistors in particular, to measure the temperature. And we put these down as many of our boreholes as we could, down to about 200 meters into the ice. And we left those sensors there as long as we could, given us about 2.5 to 3 years of continuous measurements of ice temperature. And this is going to be really useful for us because it will allow us to see if the temperature of the ice is changing over time. And if the ice is getting warmer over time, then it may well be that the warming climate is having an impact on that and the glaciers might melt faster in the future. We use maps several ways in our research, and several different types of maps to help us do our fieldwork and make these measurements. One of the first ways is using a standard map of the area, perhaps one for the national park, one that allows us to plan our fieldwork and plan where we want the boreholes on the glacier, because we wanted to cover a wide area. So we used a map to plan where our boreholes would be drilled. We also needed maps when we're actually on the glacier doing our fieldwork, so that we could navigate around, particularly if it was foggy, if the weather was bad. We needed to have a way of knowing where we were. We also use a slightly different type of map to show our results. One of the ways we've done this to show the temperature with depth in the glacier is to show a map that shows a cross-section of the glacier. So you have the glacier surface at the top, the glacier bed at the bottom, and then we can show the temperature with depth in each of our boreholes. And that's been a really effective way of displaying what we found in the ice temperature measurements. One of the other things we're doing with the results that we've collected, those ice temperature measurements, is that we're feeding them into models. One particular model that's been built for Khumbu Glacier. We're feeding in the data that we've collected, and this model then predicts how the glacier might behave in the future. It uses several different scenarios of air temperature over time, and it will predict how the glacier will melt and how long the glacier will stay around for. And one of the ways that this model shows us the results when it's finished doing its maths is that it produces maps to display the data. So this will be a map of the glacier, and this allows us to see spatial patterns in the data that we've collected. And the model shows us all sorts of things, including the melt rates over time, where the glacier is gaining mass, and how the surface is changing as the glacier is melting.